All right, we're in college algebra looking at graphs of basic functions, section 2.6. All right, this is in a nutshell what we're looking at in this first unit, the first part of the section. We have 7 different functions we're looking at here. Linear we've already talked about, which is just when you have a plain x in there. Now you can't have a multiplier, you could add or subtract, but the basic thing in all these functions is what x is doing, and this just has a plain x. So like 3x plus 2, 1/2 x minus 7, but you just have a plain x. Now quadratic is when you have x squared. So you could have 3x squared minus 5, or 3x squared plus 2, or 5x squared minus 9, or whatever, but you got x squared. And that's going to make a graph like this. Now the linear I didn't mention, but it makes a straight line. Quadratic makes a graph like this. Then you have absolute value, which makes a shape that looks like this, like a V. But the main thing is x is in this absolute value bars. Then you have the square root of x. Then you have a cubic function. You have a cube root. And then this last one on here is the integer function, which has a graph that looks like this. In each one of these now, these graphs here are all continuous, which means I can draw it with not raising my pencil off the paper. This one here is not continuous, because when I draw this one, see, when I draw this, I go to here, there, and of course this is open, and then I have to take my pencil off the paper to draw this next part. This is not continuous, but the rest of these are. Now we're going to go through each one of these. You may pause the video so you can write these down. But I'm going to go through each one, explain them a little bit. The first one we've got is quadratic. That's when f of x equals x squared. Okay? Now, let me make a table of values. So here's x, and then here's the function of x, which is the y. So if I'm going to put these values in. If I put -2 in, -2 squared would be 4. If I put -1 in for x, -1 squared would be 1. If I put 0 in for x, 0 squared would be 0, 1 squared would be 1, 2 squared would be 4. So I would have these values. And so if I graph them, okay, -2 up 4 is right here. -1 up 1 is there. 0, 0 is here. 1, 1 was there. And then 2, 4 would be there. And you can see how it makes this shape, which is called a parabola. This is the name of it. This makes a parabola. But this is used in all kinds of things. In fact, we're going to get it into some in-depth. Well, actually, we've already talked about that some. We did quadratic formula. We did some applications where you're throwing the ball in the air. So this is used a bunch in real life, this quadratic functions. But this is what it graphs, is this parabola. Okay. All right, the next one we have absolute value, which is like this right here. F of x is the absolute value of x. Okay. Now let me put some values in for it. I'm going to do the same thing. I'm going to put -2, -1, 0, 1, and 2. I'm going to put those values in. All right. So if I put -2 in there, the absolute value of -2 would be +2. If I put -1 in there, the absolute value of -1 would be +1. If I put 0 in, the absolute value of 0 would be 0. The absolute value of 1 is 1. The absolute value of 2 would be 2. So I get these values. All right, and if I graph it, -2, +2 would be here. -1, +1, 0, 0, 1, 1, 2, 2. It does this, it makes this V. Okay. All right, then the next one we have is square root. The square root function. All right, that's f of x equals the square root of x. All right, if I do these same values, -2, -1, 0, 1, 2. If I put -2 in there, the square root of -2, well, this is imaginary. That sends an I out like we've talked about before. This is imaginary, so this we can't do. -1 we can't do. Now the square root of 0 would be 0, so there's a value. The square root of 1 would be 1. Now the square root of 2, let's just change this to 4 because the square root of 2 is going to be a big decimal. We can't really graph it, but the square root of 4 would be 2. Okay, so now if I graph that one, all right, I can't do anything here. 0, 0 is here. 1, 1 is there. 2, 3, 4, 2 is here. And it does this thing, which is sort of like the parabola sideways. See, if I was to continue this thing down here, it would actually be a parabola is what it would be, a sideways one, but it just has this one part because we can't do the negatives. The negatives don't exist, so it just starts here at 0 and does this. Okay, that's the square root function. Okay. Then we have the cubic one. All right, the cubic one's when you have the f of x equals x is to the third power. Okay, well, I'll do some values for that. For x and the function of x, -2, -1, 0, 1, and 2. All right, if I do -2 to the third power, all right, -2 to the third power would be -2 times -2 times -2, which is -8. -1 to the third power would be -1. This would be 0. This would be 1, and that would be +8 if you put those in. I'm trying to speed up the process here. All right, now if I graph this, so -2, -8, 1, 2, 3, 4, 5, 6, 7, 8 would be here. -1, -1 would be there. 0, 0 is here. 1, 1 is here. And then 2, 1, 2, 3, 4, 5, 6, 7, 8 would be there. And it makes this graph, it looks like this. Okay. All right, then we have the cube root. F of x equals the third root of x. All right, basically what happens here is these switch. So I'm going to do these values, -8, -1, 0, 1, and 8. These are the numbers that you can do a cube root of. So the cube root of a -8, and you can punch these into a calculator if you need to, but this would be -2, this would be -1, 0, 1, and that would be 2. Third root of 8 would be 2. And basically what it does is it takes this graph and it just turns it sideways. It's like -8, 1, 2, 3, 4, 5, 6, 7, 8. -2 would be here. -1, -1, 0, 0, 1, 1. So you can see how it does. Okay. And there's different applications that you could do for all these. And then this last one's the integer function, or the step function, some people call it, because it makes these steps. F of x equals intx, or they put these double brackets like this. Now here's what this is right here. I know at school functions, clubs or whatever, they have fundraisers. And so kids will be given these chocolate bars to sell, the world's finest chocolate, you know, and they sell them for $1. These candy bars are $1 a piece. All right, so we're talking about the world's finest chocolate. Okay, they're $1 a piece. So if you look at the graph here, okay, and suppose this x-axis is how much money you have. So this is how much money you have. And this y-axis, this is how the number of bars, candy bars you get. Okay? All right, so suppose that you've got no money. You have $0. How many candy bars can you buy? 0. All right, suppose you have 50 cents. Now I'm going to put this little mark. This is $1. Suppose you have 50 cents. How many candy bars can you buy? You can't buy any. Suppose you have 75 cents. How many candy bars can you get? None. So when you're in right here, you cannot buy any candy bars until you get to this dollar amount. And then once you get $1, bam, you jump up here and you're at $1 now. And you can buy one candy bar. But now if you got $1.20, $1.30, $1.50, $1.80, $1.90, you're still going to be able to buy just one candy bar until you get to the $2 mark. Then once you get to the $2 mark, bam, you're up here. And now you can buy 2 candy bars. And then this thing goes on until you get to $3. And then once you get to $3, bam, you're up here and you can buy another candy bar. And it keeps going the same way. So this is how the step function can be used. This int is what's on your calculator. Let me see if I can find it real quick. Well, I thought it was on this one. There it is, right here. So if you want to do the int of $3.25, how many candy bars can you buy? You only can buy 30. You know what? Yeah, how about that? If you have $3.25, how many candy bars can you get? You only can get 3. Well, that's what the int function is. But if you do the int of negative 2.5, what would that be? That'd be negative 3. See, as you go backwards, this thing does the same thing. It just keeps going backwards like this. Okay, so if you're at negative 2.5, so negative 1, 2.5 would be right here, and that puts you down here at negative, see, this is negative 1, negative 2, and this is negative 3. And basically, the way I think about this is the highest integer, which means at negative 2.5, which is right here, the highest integer that we have attained at that point would be negative 3. We have not made it to negative 2 yet. Anyway, I don't think we're going to be dealing with the negatives much, so this is not really a thing that you have to labor over, but this is just, I'm just explaining what the function itself is. And mainly what we're going to be looking at is just being able to decipher which function is which. So let me get this on here a little bit better. Okay, so we've got something like this right here now. Which one of the graphs, which one is the graph of x squared? Okay. X squared. All right, this is the quadratic one. And looking at these right here is quadratic. So you just need to be able to pick out which one's which. This is quadratic. Now, what's the domain? What can x be on this? So as this thing goes up and up and up, it goes over and over and over forever. And then as it goes to the right, it goes up and up and up, and it goes to the right forever. So the domain would be negative infinity to positive infinity. But you can see that down here, I believe. Okay. Negative infinity, positive infinity. All right. Let's go to this next one here. And I think this should be an easy assignment. Which one's the graph of the, this is the absolute value of x. Okay, that's the one that makes the v right here, a. That's it right there. Now, what's the domain? Okay, now this says, on what open interval is it increasing? Increasing, remember, increasing as you go from left to right, it goes up. All right, so if you look at the graph, this is decreasing. All right, here, this part right here is increasing because as you go left to right, it's going up. Where does it start? It starts right here at 0. Starts right here, and it goes to infinity. So that'd be from 0 to infinity. So you can see that right here. From 0 to infinity. That's my interval, which it's increasing. Okay, number 3. All right, this is x to the third, which is cubic. Which one's the cubic function? Can you tell which one it is? That's right there, e. This one. This is cubic. All right. What's the range? What's the range of this thing? All right, range is up and down. So what's the furthest down it goes? Well, look at it here. It goes down forever. What's the furthest up it goes? Well, it goes up forever. So this would be negative infinity, positive infinity. Okay. Number 4. Which one is not the graph of a function? All right, one of these is not a function. Can you pick it out? Which one is not a function? Right here. This is not a function because if I draw my vertical line, I'm going to touch it twice. Nope, it's not a function. All right. What is its equation? All right, now what we have on this one, this is a parabola that goes sideways. Now our parabola function is this one right here. F of x equals x squared. Okay? This is my parabola function. When it goes sideways like this, it's not a function. So I can't write f of x. But what it does is it's actually x equals y squared is what this is. And you can see that down here. All right. And that's not, and back to that right there, this being x equals y squared, that's not really anything that we're going to deal with because this is not a function anyway, so we're not really going to be dealing with that much. Okay, on this one, the identity function. All right, the identity function is the same thing as the linear function. Okay, so I should have wrote that on my notes there. But the identity is linear, so that's E right here. Okay, what's the equation here? This is just f of x equals x. That's the equation. And of course it's on that the notes we did here at the beginning. Number 6. Which one is, oh, okay, this is the step function. See that? Or the integer function, we call it. Either one. Okay, so here it is, right there. Okay, now, what's the function value when x equals 0.5? So if I put 0.5 in there, what's the integer function value of 0.5? Well, that would be 0. If you have 50 cents, basically what you're thinking about here, if you have 50 cents, how many of those candy bars can you buy? Well, you can't buy any. So that would be 0. And you can see right here, 0. All right, on number 7. Okay. Which graph? This is the cube root one. All right, the cube root one. Looks like A right here. We don't have as many choices as we did on the other one. Okay. Is there any interval over which the function is decreasing? All right, decreasing as you go from left to right, it goes down. All right, if I go left to right here, look at this. If I go left to right here, this is going up. This is going up. And then it changes right here, but it's still going up. So no, this thing is never decreasing. It's always increasing. from negative infinity to positive infinity. It increases. Okay. On this one, number 8. Okay. Which one is the graph of this? Is the square root function. And what's the domain? All right, the square root function. Do you see it on there? Which one is it? Right there. This is the square root function. What's the domain? All right, on the domain, now like we talked about a minute ago, it starts right here. So the furthest to the left is 0. The furthest to the right, look here, it goes like this forever. So that'd be infinity. But it does include 0, so I got a bracket. So that would be my domain there. And you can see the answer right here. Okay. All right, then we have number 9 here. Which of the following, which graph is discontinuous? All right, discontinuous. It's not continuous. Discontinuous at many points. That's this one. These are all continuous. And basically, like I mean on continuous, you can draw it with your pencil without lifting your pencil off the paper. If you have to lift it at all, it's not continuous. So let me just draw one like this. If you have a graph that looks like this, it's not continuous because I had to lift my pencil off the paper to do that. Okay? So that's discontinuous. All right, now looking at the rest of this, it says what's the range? What's the range on this, the y values? All right, now on this here, the furthest down it goes and the furthest up it goes. Well, as you look at your range, this one here, it goes, is this -4, and between -4 and -5, there is no values here that's for the y value, and between each step, there's no y value. So it's not negative infinity to positive infinity because -2.5 is not part of the range, and any decimal value is not part of the range, just whole numbers, and it's not 0 to infinity. But this is it right here. See, I've got the braces, which means these are individual values. And see these dots right here? It goes to the left forever, and then -3, -2, -1, 0, 1, 2, 3, and then dot, dot, dot. It continues to the right forever. So this would be my range right here, C. Okay. And I think this might be the last one of this section. All right, number 10. Which graphs of functions decrease over part of the domain and increase over the rest of the domain? All right, now there's more than one answer on this. I'm pretty sure. You look and see if for sure there. Yeah, there's more than one answer on this. It says we want the function that decreases over part of the domain and increases over the rest of the domain. So it increases and decreases. Okay. Look here too. It says functions. Which function? See this one right here? This is not a function. Okay, so we can't do that one. All right. So increases and decreases. Well, look at this one here. This is decreasing, and then this is increasing. This one does. We just did this one a minute ago. See, this is increasing, 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 increasing. It never decreases, so it's not that one. This one here, as it go from left to right, this is increasing the whole time. This one here, all right, this is increasing real steeply, increasing, increase. This increases the whole time. This increases the whole time. This one, it's not increasing. This is constant. This is constant, 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 constant. It's not really increasing. And this, all right, now look here. This is decreasing, and then this is increasing. So this one. So these are the only two. Okay. All right. Now, on what open intervals do they increase? All right, so on this one here, it increases. This part right here is an increasing. So this goes from zero all the way to infinity. This graph is increasing. So there's the interval that's increasing. On this one, same thing. See, it's 0, it starts at 0, and all the way to infinity, this thing is going up. So 0 to infinity, this is increasing. Okay? All right. Now, on what open interval does it decrease? When does it decrease? Okay, so on this one, this part's decreasing right here, which is going to be from negative infinity all the way up to 0. So negative infinity to 0, this is decreasing. And on this one, same thing. See, from negative infinity all the way over to 0, this is decreasing. Okay. All right. Now we're at number 11. And we're changing gears a little bit, and we're going into what's called piecewise functions. Piecewise. Now, piecewise functions are used all the time. We don't really think about it. But like I know our cell phones used to be a piecewise function. Now there's so much competition, they just have one flat rate. But used to on your cell phone, let's talk about it as f of x. This is your piecewise function for your cell phone. And it might be, your cell phone bill might be $40 if your minutes are less than, say, 50. So $40 would buy you up to 50 minutes. I don't know, or let's say 250. That might be too low. 250 minutes. Okay, but if you go over, if your minutes go over 250, this would be maybe less than or equal to 250. But if your minutes go over 250, then it might be $40 plus 5 cents. So 5 cents times whatever your minutes are. I did X. I should have just done M. This is what your piecewise function would look like on your cell phone. So like, in other words, now, I think this would be like minus 250 is what that would be. So in other words, if you talk like 255 minutes, you've gone over your 250, so it's not going to be $40. It's going to be $40 plus 5 cents times however many minutes you go over. So this would be 255 minus 250, which would be 5. And so it would be 5 times 5 cents would be 25 cents. So it would be $40.25. And this is how cell phone bills used to be. But this is a way a piecewise function could be used and explained. And I don't know if I had that on the screen very good. But anyway, on this piecewise function here, what we're doing is we've got this piecewise function. We're wanting to figure out what these function values are. So like f of negative 3. All right, what you got to think now, this is my x value, negative 3. What's the function value of that x value? So since this is piecewise, I have to go over here and look at this part first. And I got to ask myself, all right, negative 3 is in which piece? So I just put negative 3 over here. Is negative 3 less than or equal to negative 2? Yes, it is. So it goes in this piece. So I would do 3 times negative 3, which would be negative 9. Okay, negative 2. That's my x on this one. What's the function value of negative 2? Well, I asked myself, negative 2, is negative 2 less than or equal to negative 2? Yes, it is. So it belongs in this piece. So I put negative 2 for x here. 3 times negative 2 would be negative 6. What about f of 0? All right, so that's my x value, 0. So if I put 0 in, is 0 less than or equal to negative 2? No, it's not. So it's not in that piece. So I go down to here. 0, is 0 greater than negative 2? Yes. So now this time it belongs in that piece. So I put 0 here. 0 minus 4 is negative 4. And so you just do that for each value. 2 is greater than negative 2, so it's in this piece. So 2 minus 4 would be negative 2. And then 4 is also in that piece. 4 minus 4 would be 0. Okay, there's some more of those. Here's one here. Now this one has 3 pieces. Okay. All right, so first, this is my x value. What's the function value of negative 3? So I have to see which piece it goes in. So I just start at the top one here, negative 3. Is negative 3 less than or equal to 1? Well, yeah, it is. So it goes in this piece. So I'm going to put negative 3 there. So it's going to be 4 minus 5 times negative 3. You can just punch it in your calculator, which that's going to be 15 to be 19. Okay. If I put 0 in, all right, which piece does it belong in? Well, 0, is it less than or equal to 1? Yes, so it goes in that one. So I do 4 minus 5 times 0, which is just 4. You just punch these in your calculator. 2. All right, 2, which piece does it belong in? Is 2 less than or equal to 1? No, it don't go in that piece, so we'll go down to the next one. Is 2 between 1 and 7? Yes. So it belongs in this piece now. See, 1 is less than 2, and 2 is less than 7. 2 is between those two numbers. So 2 goes here. 4 times 2 would be 8. All right, 4. Which piece is 4 in? Well, I think 4 is in this one too. See, 4 is between 1 and 7. So 4 times 4 would be 16. Okay, what about 7? What's the function value of 7? So if I put 7 in, all right, 7's not between 1 and 7. 7 is greater than or equal to 7. So 7 would go down here. So 5 times 7 is 35, plus 3 would be 38. And so there's my answers down here, you can see. Okay. All right, then we got to do some graphing of these functions. So here's one here. Which one of these is the graph, the correct graph? Okay. Now, excuse me. First thing that I do when I graph these is you look at these values over here where it transitions. See, my transition value is 2. See, at 2, it switches from this piece to that piece. So 2 is my point of issue here where it changes. So if I put 2 in this one, 2 minus 3 would be negative 1. So if I put 2 in the top piece, it'd be negative 1. All right, which is what it's supposed to do, because see, if x is 2, it would equal this. So this equals this value. So that piece is going to be colored in. Now, if I look at 2 down here in this one, okay, if I put 2 in that, it's just negative 1. Okay. Now, so both of these are the same, which means since these two values are the same here, these two pieces are going to connect. So this would be continuous. So you can see every one of these, the two pieces connect. Now, they don't always connect, but you know, every one of these you can see do. But they connect at 2, negative 1. So at 2, negative 1, looks like every one of these connect at 2, negative 1. Okay, so there's nothing we can rule out here as far as that's concerned. Now, let's look at this top piece. Let's pick a value of x that's less than or equal to 2. All right, well, let's do 0. 0 is less than or equal to 2. All right, so if I put 0 in, 0 minus 3 would be negative 3. So on this piece, now, these are usually in order, so this piece to the left, this top one's to the left, this is to the right. It should have 0, negative 3 as a point. So if I look at 0, negative 3, 0, negative 3 would be right here. So that one's a possibility. 0, negative 3 would be here, and this one's out because it doesn't go to that point. 0, negative 3, nope. 0, negative 3, nope. I think we got the right piece right there, A. Now, if there was two possibilities on that one, all right, like suppose this one here had this part that goes like this, like that does. Okay, and so that's a possibility. It could be this one. All right, then I would have to go to this other piece, and I'd have to look at it. So on that one, I would pick a value of x that's greater than 2, like maybe 4. Okay, so if I put 4 in, well, 4, it's automatically negative 1. So we're looking at 1, 2, 3, 4, negative 1. See right there. So you determine that's that piece, whereas here 4, negative 1 does not get that piece. Okay. We'll do some more. If you don't understand it yet, we've got plenty of these to do. All right. So on this one, which graph is this one? Now see, look at this. These are not continuous. They're discontinuous. Okay. So we look at our transition value first, which is 1. So if I put 1 in that piece versus putting 1 in that piece. All right, if I put 1 in here, negative 2 minus 1 would be negative 3. Okay, now look here. X can equal 1 on this one. So this value here is equal, which means this will be colored in. Versus now down here, if I put 1 in this, negative 3 minus 2 times 1 would be negative, did I say minus? Negative 3 plus 2 times 1, which would be negative 1. Okay, but this one here, X does not equal 1 for that piece. So this is a point that's not colored in because it doesn't equal that value there. But it goes towards it. So we do consider that point. So that's why these are colored and not colored. Okay, so this one here, see, when I put my transition value 1 in here, it does equal that one, so it is colored in for it. But see, when I put 1 in there, it does not equal it, so it's not colored in. All right, so we could just look at the points first and see which ones have the endpoints. Maybe that might rule some out. So if I look at 1, negative 3, so at 1, negative 1, 2, 3 would be here. That should be colored in, and it's not on this one. All right, here it is, colored in here. So that one's good. And then on the other piece, 1, negative 1 should be right here. That's not the right point there. See, it's positive 1. That's not it. This is not right. Here's the graph right here. Just looking at the 2 points here. See here, 1, negative 3. 1, negative 3 is colored in. And then 1, negative 1 is open. This is the only one of the graphs that has those 2 pieces. So I know that's it. I can just select that as my answer. All right, but suppose there was 2 that had those points. Which one would it be then? All right, then you got to go into the function and you got to pick a value of x that's less than or equal to 1, like maybe 0. If I put 0 in, negative 2 minus 0 would be negative 2. So this should be a point on that graph. So if I do 0, negative 2, see there how it's on the graph? Okay, and then on this one here, to find another point on it, to make sure which graph it is, I would pick a value of x that's greater than 1 for this piece. Like I could do 2 or 3 or 4 even. And if I put 4 in there, I got negative 3 plus 2 times 4, which would be 5. Okay, so that means on 4, 1, 2, 3, 4, up 1, 2, 3, 4, 5. It looks like it hits it right there. So that's definitely the answer. Okay. All right, let's look at the next one here, 15. Graph the following piecewise function. All right, now look here. Negative 3, negative 1. These are both horizontal lines because this is f of x, which is y, equals negative 3, y equals negative 1. There's no x. There's no x in either one, which means it's parallel to the x-axis. It does not cross the x-axis, which you can see all these are. Okay, so, all right, so let's look at my transition value, 2. So if I put 2 in this one versus putting 2 in that one. If I put 2 in this one, it's negative 3. If I put 2 in that one, it's negative 1. Okay, automatically. See, it's automatically negative 3. Now on this one here, see, it's got the equal to bar. So this one should be colored in because it's got the equal to bar. Whereas this one, see, x does not equal 2 in this one, so it's not part of that piece, which means it's open like this. So that's the first thing we look at, those transition points. This one and this one colored in. So at 2, negative 3, here, I'm just going to graph it like this. 2, negative 3, that should be colored in. And then at 2, negative 1, it's not colored in. So I should have these 2 points that look like this. All right, both of these. See, both of these have those 2 points colored in correctly. These are not colored correctly. Okay? See there? This was 2, -3. This was 2, -1. This one's colored in because it's equal to, but this one's not colored in because it's not equal to. So that would be my 2 points, which is either one of these. All right, now how do you determine which one it is? All right, so you got to do this extra point. So like I got to pick something for x that's less than 2, well, like 0. Now if I put 0 in there, it should be -3. Okay, I think this will tell us which one's the answer. So at 0, -3, this should be colored in, and it's not. See here, 0, -3, this one is. This is my answer right here, this is not. Now, if you still couldn't tell, then you go to this piece and you pick a value of x that's greater than 2, like maybe 4 or 3 or whatever. But if I put 4 in there, it's -1 automatically. So see at 4, 1, 2, 3, 4, -1 right there. Okay, so that's definitely my answer. Okay. All right, 16 here. All right, now 16, we've got to come up with the answer on this. We've got to figure out what the answer is. Well, I can see here both of these are horizontal, which means that's y equals, because it does not cross the x-axis, it has no x in it. So this one here, this would be y equals 2, then this would be y equals -1. Okay? All right, so, but instead of y, we got f of x. So on this top piece right here, this is going to be f of x equals, this would just be 2. But now this is when x is less than or equal to 0. Okay. There's 2 options here, option A and option B. Now look, this has to be less than or equal to, because see how it's colored in? See how it's colored in right there? So it's got to be less than or equal to 0. So this would not be the option. On this one, this piece is greater than 1. So this would be greater than 1. And of course, it's y equals -1, or f of x equals -1. Okay. All right, so now down here, what's the domain? Okay, my domain, this one here, this is continuous, so it goes to, this would be -infinity all the way up to 0, and it does include 0. All right, so we're going to have this down here, -infinity to 0 with a bracket, and then we'll have a union, because I got another piece down here, but it starts at 1, and it's not included, and it goes to positive infinity. It goes that way forever. So that'd be my domain. Okay, now what's my range on this? Range is my y values up and down. Well, look, I just have 2 y values is all I have. I've got -1 down here, and I got 2 up there for the y values. So I'm going to do that in these braces. I just have -1, and I've got 2. That's the only 2 values of y I have. Okay. All right. What about this one? All right, here's, we've got a horizontal line, and then we got this line that's not horizontal. So on this one here, it does not cross the x-axis, so there's no x in it. So it's just y equals, what is that, 4? So this is y equals 4. Okay. But this one here, now this is a linear equation. All right. Now, if you look at this line right here, okay, see how it goes to this point to that point? So it's going to go to this point, it's going to go to this point, it's going to go to this point, which, see, it crosses at 0. So this is just y equals x, because it's going up 1 over 1, so it's just 1 over 1, or it's just 1x, and it crosses at 0, so the y-intercept would be plus 0, but it's just y equals x is what it is. Okay, now, so this top piece is the one to the left. So the one to the left would be this one here, which I drew this right here. This is not part of it. This is the part to the left. Okay, and it starts at negative infinity and goes up to negative, it goes from negative infinity all the way to negative 3. So this is when x is less than or equal to negative 3. And it's less than or equal to, not less than. So this is not the option. This is the option because, see, the less than, the part to the left, it's colored in. The part to the right here, this one here, is not colored in, so it's greater than negative 3. So see that negative 3, it's greater than here, less than there, colored in. So the less than is colored in. And then we said here, on this piece right here, this is just x. And then down here on this one, we said this was 4. Okay. Now what's my domain and my range? Okay, my domain on this, on this piece right here, what's the furthest to the left it goes? Well, it goes to negative infinity, and it goes all the way up to negative 3. So let me just write it. It goes from negative infinity all the way up to negative 3, and it includes negative 3. All right, then on this piece, it starts at negative 3. It does not include it. Then it goes to positive infinity. Okay, but now if you notice this goes from negative infinity to negative 3, and includes it, and then this goes from negative 3 to infinity. So actually every x value is included here. So actually my domain is just negative infinity to positive infinity. Every x value is included in it. Now what about my range? All right, on my range, this piece right here, it goes down forever, and it goes up to negative 3. So this goes from negative infinity up to negative 3. And it does include negative 3, so I put brackets. Okay. I don't know if I can get both of them on there where you see them at the same time. So that's what this piece is. Now this piece right here, that's just 4. So notice here, I got this union here, and these has braces. That's 4. So we've got a union here. We've got this interval for this piece here that goes down forever. And then we have this piece here that's in braces because it's just that one value. And so that would be my range on that. All right, and then last two problems, and number 18. Okay, sketch a graph that depicts the amount of water in a 75-gallon tank. The tank is initially empty and then filled at a rate of 10 gallons per minute. Immediately after it's full, a pump is used to empty the tank at 3 gallons per minute. Okay, now which one's the correct graph here? All right, well, the tank is initially empty, which means these two right here are out, because you see at 0 initially at the beginning of this thing, this is not empty. It looks like it's got some in the tank. Same thing here. See, it looks like it has some in the tank. So both of these are possibilities here, because see, at 0, it's 0. Initially, it's empty. So at time, in minutes, see, these are minutes, it has 0 gallons. At 0 minutes, it has 0 gallons. 0 minutes, 0 gallons. Okay? Now, it's filled at a rate of 10 gallons per minute, and then after it's full, it empties at 3 gallons per minute, which means it's filling it faster than what it's emptying it. So it's going to fill it at 10 gallons per minute, which fills it real fast, and then it's going to empty it at 3 gallons per minute, which is a lot slower. Or that would be this then. Because you can see here, this is real fast. It fills it up to 75 gallons, and then it empties it out slowly over a period of time. So this would be the answer. This is actually backwards. This was like filling it at 3 gallons per minute, and this is emptying it at 10 gallons per minute. That's not it. This is it here. Okay. And then the last one here, and this is a good piecewise function application right here. The light vehicle market share in percent in a particular country for pickup trucks is shown in the graph. So this is for pickup trucks. Let x equals 0 represent 1995. X equals 4 is 1999, and so on. Okay, so now if you need to, you can make a little table here. X is 0, 1, 2, 3, 4. Then the year 0 would be 1995. This would be 1996. This would be 1997. This would be 1998. This would be 1999, which it says 4 is 1999, and so on. It just continues this up. Okay, so use the points on the graph to write equations for the line segments in these intervals from 0 to 4 and from 4 to 8. It says define this graph as piecewise function of x. All right, so if you go from 0 to 4, all right, 0 to 4, and notice how these have brackets. So this equals 0 and that equals 4. So here's 0 and then here's 4. Basically, I'm just going to take these 2 points and find a linear equation like we've done before. So let's just take those points, 0, 42.2, and 4, 39.3. We're just going to find the linear equation of this. So first we find the slope. Remember the slope, y2 minus y1, x2 minus x1. So my y in point 2, 39.3, minus my y in point 1, 42.2. My x in point 2 is 4. My x in point 1 is 0. Okay. All right, so what's my slope there? All right, let's bring the calculator in. And we're going to do 39.3 minus 42.2. And it's going to be negative 2.9 over 4 minus 0 is 4. And so we're just going to divide by 4 here. And that's going to be negative 0.725. Now, let's see, does it say to use integers or decimals for any numbers in expressions? Okay, so we're going to leave this right here. So there's my slope. It says use decimals, so there you go, there's my slope. Okay. Now, what's the y-intercept? So here's my 2 points. I'm going to pick, well, here, look here. There's my y-intercept because x is 0. See, the y-intercept is when x is 0. So there's my y-intercept right there. So we're good. This is y equals negative 0.725x, and then plus this number. All right, there's my equation here. So for this one, y equals, I'm going to have negative 0.725x plus 42.2. Okay? Now, what's the equation for this one? So I do the same exact thing. I'm going to take the interval 4 to 8. So which means I'm going to take these 2 points. All right, so we're going to do the same thing then. I'm going to take 4, 39.3. I'm going to take 8, 32.5, and we'll find the equation of the line between those 2 points. Okay, so let's just move this up here. So my slope, I'm going to do 32.5 minus 39.3 over 8 minus 4. Okay, so 32.5 minus 39.3, okay, that's going to be negative 6.8, and then 8 minus 4 is 4, and so I divide that. All right, this is going to be negative 1.7. There's my slope. Okay, so that means y equals negative 1.7x plus my y-intercept. I don't know that one, and I don't have a 0 like I did on that first one, so I'm going to have to figure out my y-intercept this time. All right, which means I got to take one of these points and put it in. So let's just take, I don't know, let's take this one here. I'm going to put 4 in for x. I'm going to put 39.3 in for y. Okay, So 39.3 equals, all right, I'm going to multiply that. That's going to be like negative 6.8, I think. Negative 1.7 times 4, yep, negative 6.8. And I'm going to add 6.8. So B equals, it's going to be 11, 1, 10, 16, 1, 46.1. Okay, so there's my y-intercept. So there's my slope, there's my y-intercept, which means I have this line, y equals negative 1.7x plus 46.1. This is my equation, and so that goes in right here. Negative 1.7x plus 46.1. Okay, so these are my two linear equations. So look at the graph now. So this piece right here, this line is that equation. And then this piece right here, that line is this equation. But it's only between these intervals, either from 4 to 8, and this was from 0 to 4, that line, and from 4 to 8 would be that line. Okay? Well, we can write this as a piecewise function here. So the function of x, which function of x is the y, so between 0 and 4, I'm going to have this. So this right here should be here. So I'm going to have negative 0.725x plus 42.2. And then from 4 to 8, I'm going to have that one. So this is going to be negative 1.7x plus 46.1. And that's my piecewise function. Okay? And here's my answers down here. You can see I'm all right. Okay? All right, so I think we've gone through, I believe that's, yeah, I think it's it. So this is Graphs of Basic Functions, section 2.6. And if you have any questions, contact me and I'll try to help you all I can. Have a great rest of the day.